Iceberg and DataFusion Comet. We will have a quick self-intro first.
We're good. Don't worry about that.
My name is Huaxin. I'm a PMC member of Apache Spark, and I'm also a committer of Apache Iceberg and Apache DataFusion Comet.
And I'm Parth Chandra. I'm a PMC member of Apache Drill and Apache Arrow. And I'm also a committer in Apache DataFusion Comet. And we also have in the audience the founder of the Comet project, Huaxin, sitting in the third row.
So here is today's agenda. First, we will give a brief overview of Comet. And then we'll talk about how we integrate Comet with Iceberg. We will also show you the performance benchmark so you will see how fast Comet is. After that, we will talk about some of the challenges we have encountered and how we address these challenges. We will also share with the development roadmap and talk about the Comet community.
So here's a quick introduction to DataFusion Comet. So Comet is an accelerator for Apache Spark. It is built on top of the Apache DataFusion database engine, and it is implemented as an extension of Apache Spark.
We started to work on this Comet project about 3 years ago. The reason we want to work on Comet is because there are some performance challenges with Spark. So first of all, Spark was designed as a row-based model. So the iterator will fetch only one row at a time. It cannot take advantage of the vectorized operations, and there are quite some overheads. Spark actually has this whole state coding to mitigate against this overhead in row-based model. It's quite successful and improves Spark performance a lot. But there are limitations on the amount of code that can be generated. If the limitation is exceeded, Spark will fall back to the row-based volcano model. Another problem with Comet is that another problem with Spark is Spark is JVM based. So the JVM execution tends to be slower than the native execution. And also for memory usage, JVM tends to have a higher memory consumption than native execution. And also the garbage collection always slow down the performance. So because of these problems, it is very hard to improve Spark performance further. That's why lots of people started to explore other alternatives to accelerate Spark, mainly from native execution side.
So Comet acts as a performance booster for Apache Spark. It converts Spark physical plans into native plans. The native plans are executed in native code. Comet aims for 100% compatibility with Spark in everything. Where we do not support a Spark operation, we fall back to Spark. At the moment, we have support for 11 different Spark operators, about 118 expressions, and just for comparison, Spark has 200 very commonly used expressions, and we're continuing to work on providing support for those. Here's a look at what it looks like in the overall architecture. You all recognize that Spark has a Spark driver, which runs the application, and that launches through the Spark scheduler a bunch of Spark executors. So Comet has a component that sits and executes on the driver side. It also has a component that will sit and execute on the executor side. On the driver side, the Comet component interacts with the Spark planner, takes the Spark plan and converts it into a Comet plan. And on the executor side, the Comet component takes that actual Comet plan and executes it and gives data back to the JVM. Looking deeper inside, this is what we just talked about. The Spark logical plan is converted into a Spark physical plan by Spark. The physical plan comes into Comet. Comet converts it into a intermediate representation. This representation is in protobuf. And at execution time, this plan is sent over to the executors. On the executor side, the same Comet component takes the protobuf representation, deserializes it, converts it into a Comet plan, which is then passed into the corresponding DataFusion operations. And all the data that is interchanged between DataFusion and Comet and Spark is done using Apache Arrow. If there are any shuffle files that need to be written, they're written by the native component.
Since we have some performance gain in Comet, we want to integrate Comet with Iceberg. So Iceberg will benefit from the same performance gain. So thanks for the help from the Iceberg community. We were able to introduce Comet as a first-class citizen in Iceberg. So for this Comet Iceberg integration, we mainly get performance improvement in two ways. The first way is that when doing the Iceberg table scan, we are able to leverage Comet packet reader, so we can read the packet data faster. Another way to improve the performance is that we can convert the Spark plan to native plan, and then we execute this plan natively. So we actually can gain quite some performance improvement here.
So coming into a pictorial representation of how Iceberg integrates into this architecture, we start from the picture that we had in the previous slides. And we have a Spark component here. Let's say we have some operations here, a filter or project and a scan. When Comet gets this plan, Comet converts the operations into the corresponding native operators. So Comet filter, Comet project, and a Comet batch scan. And at execution time, Comet batch scan wraps an Iceberg batch scan around inside it. So at execution time, the Iceberg batch scan calls its vectorized parquet reader, and if Comet is enabled, then the vectorized parquet reader will call Comet's column reader. And Comet's column reader then calls Comet's parquet reader, and then the data is sent all the way back.
So let's take a closer look of this Comet packet reader. This Comet packet reader is a hybrid implementation. It does I/O and decompression in JVM, but it does the decoding at a native. So basically, the native code will be invoked to decode packet data into arrow format. So we can get some performance gain from here. In order to enable Comet packet reader in Iceberg, we have introduced this new enum type, packet reader type. So there are two types inside this new enum type. We have a Iceberg type. It utilizes the existing built-in packet reader, and it also has a Comet type. It will switch the packet reader to DataFusion Comet's packet reader. We have also introduced this new Spark SQL property packet reader type. The the default of this new property is Iceberg. But if the user want to take advantage of Comet packet reader, he can simply configure this to Comet, and then Iceberg will use Comet packet reader. So inside the Iceberg code, there is a base batch reader, and inside it there is a method called new packet iterable. So basically, it will check the packet reader type. If the reader type is Comet, it will create a Comet column reader for each of the columns. And then the Comet column reader will decode packet data natively to arrow vectors and construct a Spark column batch from it. As I mentioned earlier, another way we get the performance gain is from the native execution. So in order to turn on the Comet native execution, on Comet side, we have a Comet Spark session extension. It can detect the Iceberg table scan and then convert the Iceberg table scan into a Comet batch scan. And then Comet will convert each of the Spark operators into the corresponding native operators and construct a native basic plan from it. And then this native plan will be executed in DataFusion. In order for us to turn on Comet native execution, in Iceberg, we need to make this Spark scan to implement support Comet interface. In this interface, there is only one method. It's Comet enabled. So basically, if the user sets the configuration to Comet, and also the batch read task is true, we will return true for this method. And then on Comet side, we will check the support Comet method. So basically, in Comet side, we have a scan rule. In this scan rule, we will traverse the plan tree, and we will see if there is Iceberg table scan. We will check the support Comet. If it's true, we will convert the Iceberg scan into a Comet scan. In the same class, we also have a Comet execute rule. This rule will basically check the plan tree from bottom up and convert each of the Spark operator to the corresponding native operator. So we can generate a native physical plan from it. So this can be executed in native.
So after all the coding is done, first question people have is, how much faster did it get? So naturally, we ran a TPC-H benchmark. We used Iceberg 1.8. We applied this PR 12709. This PR was required to actually have the benchmark run successfully at scale. We used Spark 3.4. We used Comet 0.7.0, which is the latest Comet release. We ran it on a scale factor of SF1000, which is a 1 terabyte data set, and the environment was EKS and S3 as the storage. We used 10 executor instances. There were 16 cores in each executor, and we gave each executor 128 gigs of memory. Otherwise, all configurations were the same. The difference between Comet and Spark was that with Spark, we gave 96 gigs of memory to the executor and only 16 gigs to off-heap memory. On the Comet side, we reduced the executor memory to 48 gigs. This is the memory in the JVM. And we increased the off-heap memory size to 64 gigs. And so this is required because Comet executes in native code. It cannot really use JVM memory. But we did give the same amount of extra memory to Spark. And the result is that we were nearly 2 times faster than Spark. Yeah, you may clap. Oh, thank you. Thank you, that made out A. So query 1 was a little over 6 times faster. There were some queries like, I think queries 19 and 20, which were just barely faster than Spark, but none of the queries was slower than Spark. And we did this with the same amount of resources, right? And as I mentioned, 1.96 times faster overall for the total benchmark. So this is query 1. You don't need to read the query. So the top half is the Spark plan. The bottom half is the corresponding Comet plan. And the plans are nearly the same, except that the Spark operators have all been replaced by Comet operators, and except for the AQE part. And all the execution, basically nearly everything, happened in native code. And that's where all the speed up came from. This is the official benchmark, which is published by the DataFusion Comet project. This runs on a single node. It's only 100 gigs of data. It uses only local Parquet files. But it gives you a very good idea of comparative performances. And this was run with Spark 3.4. With Comet 0.7, it's about 2.2 times faster, which is slightly faster than our Iceberg integration. And if you look at the underlying DataFusion engine, that's 3.6 times faster. So we have some room for improvement and getting to run even faster and faster with Iceberg.
So in order to close the gap between the benchmark result between DataFusion and the benchmark result between Comet Iceberg integration, there are several things we plan to work on. First of all, right now, not all the query run in fully native yet, because there are some missing features, and also because some of the operators are not supported in native yet. So, for example, right now, for query 5, 7, and 8, and also for query 20 and 21, we don't have support for bloom filter aggregate. Also for query 16, we don't have support for broadcast hash join if it's null-aware anti-join. So in the future, we plan to support all these missing features and plan to support all the operators so they can run fully natively. So we can have even faster benchmark result. Another thing we plan to do is to avoid unpacking dictionary arrays before joins. But this one needs to be done in the upstream in DataFusion. One more thing we want to do is to implement common sub-expression elimination physical optimizer rule. Currently, DataFusion has a logical rule for this. But in order for Comet to take advantage of the optimizer rule, we need also to implement the corresponding one in the physical side.
So we faced a whole bunch of challenges as we were doing this. First set of challenges comes from data type mismatches or incompatibilities. So we start with Parquet, which has its own data types. Then we have Iceberg, which has its own data types. Then we have Comet and Arrow, which have their own data types. And then we have Spark, which have their own data types. And as data moves along this pipeline, there are subtle incompatibilities that can occur. And as a result, some types like Iceberg UUID is not even supported right now. For the most part, though, we've managed to overcome those. We also hit a whole bunch of issues with respect to shading in Parquet. Iceberg has its own version of Parquet, Comet had its own version of Parquet, Spark has its own version of Parquet, and each of the libraries is trying to shade Parquet. But during this integration, we actually found that we had to reach back into the Parquet implementation used by Iceberg in order to get some information from there. And that was a bit of a challenge. But in general, one of our bigger challenges has been memory use. So one of the things that I mentioned while I was talking about the configuration for running the benchmark was that we had to carefully manage the memory and move some memory away from the JVM into off-heap memory. Now this is very, very important. Without that, Comet fails to run successfully. And this is something that end users have to do manually. So it becomes a little bit of a challenge in trying to understand how to get Comet to run successfully. Meanwhile, we are continuing to improve memory usage, and in fact, reduce memory usage as much as we can without losing any speed, especially during shuffles. And these memory improvements are, some of them are going to be available in the next release of Comet, which will be maybe in another month or so. One of our other big challenges is Spark compatibility. Now, Spark is the reason for Comet to exist. So it is extremely important for Comet to produce data which is the same as the data that Spark would have produced. But every now and then we find that for certain specific types, for certain boundary conditions, we find that DataFusion or Comet produces is just not the same as Spark. And sometimes it's just not possible to change it. And this usually happens at the very end of, say, at the boundary conditions of, say, unsigned integers, which are handled differently in native code and which are handled differently in the JVM. As a result of that, Comet's ANSI support is still experimental. This is going to be a little bit of a challenge with Spark 4.0, where ANSI support is the default. And we are continuing to add coverage in our internal implementations to make sure that we handle ANSI support successfully and correctly in accordance with the way that Spark will handle it. And finally, one more tricky thing that comes our way is that cast options are a Spark configuration option. So their Spark configuration options can modify the way a cast may behave. So that requires us to have multiple implementations sometimes where we take a single value or we could output a different value based on the configuration option.
We also want to share our development roadmap. So here are some of the potential features we're thinking of working on. The first one is to support the parallel I/O for Comet Iceberg integration. So actually, in Comet, Comet has its own Parquet file reader. The Comet Parquet file reader uses multi-threading to download Parquet data in parallel, so it's faster. So we're thinking of in the future, we probably can replace the Iceberg Parquet file reader with the Comet Parquet reader, so we can read Parquet faster. Another thing we need to work on is to support deletes in Comet Iceberg integration. Currently, we don't support this yet. We fall back to Iceberg Parquet reader for deletes. So in the future, we need to pass deletes info to Comet and keep reading the deleted rows.
One of the big features that we're working on is supporting complex data types. Now this is complex data types, structs, maps, arrays, across the board, all the way from scan to operations and expressions. So Comet now already has support for many array functions and many struct functions. The Comet scan does not currently support complex data types. So what we're adding is a couple of options to enable a native reader that supports complex data types. We're implementing this as a Comet native scan operator that will, under the covers, use the Arrow Parquet reader. And this will be fully vectorized. It'll use Arrow as the in-memory format. It will be fully native, and it'll have all the support. It also has a few high-performance features, including parallel reading of files and row groups, and also does some very good pipelining under the covers. We also are implementing a set of APIs built on top of the same interface. And these APIs are the same APIs that our current integration with Iceberg uses. So what that means is that down the road, once we have the Comet native scan operator fully baked and fully functional, we'll be only one step away from making that available in Iceberg. Now, this is a very big deal for Iceberg. And the reason it's a very big deal for Iceberg is that Iceberg's got complex type support, but that complex type reader is now vectorized. And this provides us with both a vectorized reader and a native implementation and support for complex types. So we expect huge performance gains over there. And of course, we will continue to work on adding more and more coverage for Spark operators and expressions. So one of the things we need is help from the community. So here's a quick look at what the Comet community looks like. Comet was open sourced in February last year under Apache DataFusion. Apache DataFusion is a top-level Apache project. We have over 65 contributors as of today, 194 forks, 925 stars. And we do have regular meetings that everybody is invited to attend and contribute to, or you can just join our mailing list.
We warmly welcome contribution to Comet. So if you are interested to make a contribution to Comet, you can start with good first issues. You can check out our contribution guide. There are plenty of beginner-friendly tasks you can start with. Another way to make a contribution is to test Comet with Spark jobs. You can run Comet on your existing Spark workload and report any bugs or performance issues to us. We also need some help on optimizing performance. You can help us enhance metrics, refine code, and identify areas for improvement. So with your help, we can make Comet even faster. So in next year's Iceberg Summit, we can present even more amazing benchmark number. Okay, that's all we have for today. Thank you.
Well, thanks so much. That was a really great talk, and I'm sure we've got questions all over the place. So I'm gonna start in the back, and we'll come forwards. All right.
Thank you. Thank you very much. I think it's a very informative presentation. So my question is like, today we know like from Iceberg v3, we're going to support geotype internally. Like I know Comet will still support like more complex type, I'm assuming including geotype in the future. So my question is what's the best way you think, maybe support, some of the physical type like this? Will Comet eventually support UDT type as a, as some kind of trade-off? Yeah, thank you.
So our approach is pretty much to use whatever is available in Apache. And
That's great. And just a feedback from me, they are working on an Arrow RS variant reader right now. So the PR is up. Go check it out if you want to encourage this development.
Yeah, hi. A two-part question. Do you have TPC-DS numbers also in progress or something like that? Okay. Got it. And this looks very similar to the Velox project. So do you have any trade-offs that you guys have identified?
Hi, can I use Comet today with the latest Iceberg version and the latest Spark version? I saw that you benchmark at Spark 3.4. Does it work with 3.5.4? Got it. No, 3.5. Okay.
Hi. Assuming that the Comet operators have, you know, different performance characteristics than the Spark operators, is there any plan to change kind of higher level elements in the plan in the future? For example, varying the number of shuffle partitions that the Comet plan will ultimately use?
All right. Any other questions?
Do you support Avro reads?
Yeah, that was a quick one.
One question about the benchmarks you did. So you gave both the same amount of memory. Did you also monitor actual memory usage? So was there a difference between the two? Or did both need approximately same?
Thanks for the talk. You mentioned that the decompression and I/O occurs in JVM and the decoding in the native code. Can you talk about that design choice? Like, why not everything in native?
I think in the beginning, we had some idea or some effort in that direction, which is do the file I/O as well in, in native. I think we had some doubts about whether decompression and decryption would be easily available in native code. And at the time that this implementation was done, encryption support did not exist, especially not in the Rust layer, which is where we required that implementation. That has since then changed. And so our new implementations will likely try to go with this.
Cool. Any other? Okay. So many questions.
I'm sorry. And great talk, by the way. So a question is on the TPC-H benchmark query 10, 19, 20, there are no significant gain. So can you shed some light in terms of like, is some operator not support or something like that?
No. Most of the, I think the question read out that list of some of the features that were missing. I think that was mostly the reason why we were not faster. Because like I said, at worst, some parts execute in native and some parts execute in JVM. Wherever we don't support it, we just fall back to Spark, right? But when we go between native and JVM, we incur some overhead. And so the native code has to run faster to make up for that overhead, even if it is to just keep it at the same performance level. But yes, mostly it's because we are not covering the entire area, the entire query.
Thanks for the great talk. I hope simple question. So what are my sort of challenges if I would like to use Comet in this case as a drop-in replacement of whatever I do with the Spark now? Is there anything I need to know, or I can just try and go on? So are there any known issues with like Comet saving as a drop-in replacement? Thank you.
So off the top of my head, I would like to say, yeah, you're not going to have any issues, but yes, we do have people coming on the mailing lists saying we tried this and nothing worked. And the second most common complaint is we tried this and it did not run fast enough. The most common reasons I've found heard of where people have an issue with starting using Comet is because there's a native component and the official Comet implementation does not have, for instance, support for Apple Silicon-based Macs. That binary does not exist in the published jar file. And people have tried it, running it. I ran this on my Mac and it just doesn't work. So well, it took a while to figure that out, right? That's one. There are some other cases where people have, for instance, tried using it on some specific internal version of Spark. Or in one case, there was someone in the classic version of Spark, which had small API differences. And we do make calls to internal APIs of Spark, which are not really public. So the public APIs don't change, but the private APIs may. But we do sometimes cheat and use those APIs. And if you're using a private version of Spark, then, well, it just doesn't work. The third most common issue that people have is really just related to enabling the right set of configurations. And at least in the DataFusion Comet documentation, we keep adding every little bit of information that we find. We keep adding that to our documentation and our starting guide and so on, just to help people make sure that when they start trying to do things, things just work at least. And then the third part, the last part is just trying to get it to run faster, because the first time around, half the people, I
All right, I think that's about all the time we have for now, so everyone please give another round of applause to Huaxin and Parth. Please remember